Hey guys, welcome to 2.6 Related Rates Day 2, Part 2. In this video we're going to be doing the last two problems of the worksheet. So let's begin with the first example. A man 6 feet tall is walking at a rate of 5 feet per second toward a light pole, 16 feet tall. At what rate is the tip of his shadow moving when he is 10 feet from the base of the light? And at what rate is his length of the shadow moving when he is 10 feet from the base of the light? So let's go ahead and draw a picture. Here's a light pole, and here's a 6-foot man walking towards it at a rate of 5 feet per second. Now, when light shines upon this man, we have this triangle here. Now, this part of the triangle that I'm bolding here would represent his shadow. So let's go ahead and label the dimensions of this pole. 16. This man here is 6. I notice that I have two triangles actually. And I have two triangles. The red one is similar to the black one, so that means that they're proportional to each other. So we'll get to that in a bit. So we want to find out at what rate his tip of his shadow is moving when he is moving towards the light. So here's the tip of his shadow, that dot that I'm drawing right there. We're going to call this distance from the pole to the tip, we're going to call this distance y. And we're going to call this distance from the pole to the man x. Now we don't know what y and x are because they're always changing because he's walking towards the pole. Okay, now what would the distance be from the man to the tip of his shadow? That distance would be y minus x. It would be the difference of y and x, so y minus x would be the distance of his shadow. Now, since we have two similar triangles, we can write a proportion. I'm going to go ahead and write the heights of these triangles as a ratio. And I'm going to write the adjacent of these two triangles also as a ratio. In order for this to work, you got to keep the ratio consistent with each other. I took the height of the larger over the height of the smaller, and then the adjacent of the larger over the adjacent of the smaller. If you mix up the ratio, then you'll have a wrong answer. So, solving for this equation, we want to solve for y. So we're going to cross multiply. 16y minus 16x is equal to 6y. That would be the same thing as 10y is equal to 16x. And finally, y is equal to 16 over 10x. Okay, so let's go back to letter A. At what rate is the tip of his shadow moving? Well, since y represents the distance from the pole to the tip of his shadow, then the change of that would be dy dt. So we need to find dy dt. How do we find dy dt given y? Take the derivative with respect to time, and you get dy dt is equal to 16 over 10 dx dt. Now dx dt is given to us, so that's going to be 16 over 10 times 5, and that is the same thing as 8 feet per second. So when the man is walking towards the pole, his shadow is changing at 8 feet per second. That is letter A. Letter B. Letter B says, what is the rate? At what rate is the length of his shadow moving when he is 10 feet away from the base of the light? Well, the length of his shadow is defined by y minus x. And if we want to find the rate of that length of the shadow, then we got to take the derivative with respect to time of y minus x, which will give us dy dt minus dx dt. Since we know what dy dt is and dx dt is, we can say that it's 3 feet per second. And that's it for this example.